How are you guys all spending it?
Let me introduce you, Kliman. Please introduce Ricky first.
Yeah, sure.
Okay.
Before we start, let me just introduce to Mr. Ricky Young. Ricky is a software engineer and COO of qBraid. He graduated from Stanford University with a bachelor in engineering physics, and he's going to introduce the qBraid platform for quantum computing today. So without further ado, I'll pass it on to Ricky. Please feel comfortable and welcome.
Cool, awesome. Thank you so much.
Yeah.
And with that, I'd like to just kind of get started with a quick presentation. And I think we can also do kind of like a live demo first and foremost. How many of you guys have used qBraid before? Like, if someone could give me a reaction here. Is this everyone's first time? Let's see. I think so. If that's the case, that's really awesome. I'm really happy to be here and just kind of show off what we do. And I'll just start off with the presentation and then provide you guys some information about how, if you're getting started in quantum computing, if you want to use some high performance compute that's classical, that also is very easy with qBraid as well. So with that said, so I'm going to give a quick overview of why we started this and then providing access as well. Then we'll get into how to use parts of our platform. So how many of you guys have ever ran into a pip dependency issue or like pip install and then some kind of conflict occurs? If you have, it's really, really annoying. And yeah, right, like it's very annoying. And if you have recently checked out packages like Qiskit, they kind of deprecate a lot of modules every 6 months. In fact, the way you access quantum computers through them has just changed, where you install 3 different packages for running essentially experiments or accessing quantum computers just for circuits. And so it can be a little bit tricky sometimes when your code just starts to break, and that's why qBraid was built. And so that's where we've taken care of a lot of the classical stack, and then you have like your quantum stack all available to you. And you'll see this bar I'll show. It's essentially how you can access a lot of these quantum computing environments. Everything is all ready for you. And then we also have an SDK as well. So the SDK allows you to write in any of these languages and then submit jobs to any of these backends as well. Any questions so far? All right. If there aren't any questions, I'd like to first take everyone to here. This is the qBraid.com page. And here, once you've signed in, or if you've created an account, I recommend using Google. It's only like a single click. It's very quick. You can actually be greeted by our page here, where you can actually have the opportunity to use our course. It's completely free. And we actually provide so essentially we have our course as well, and then you'll be able to see your quantum jobs, be able to run and be part of our hackathons. Have you guys been part of MIT iQuack? Want to see some of your hands raised. Anyone been part of MIT iQuack? All right, maybe not, but that's okay. MIT iQuack is really great in terms of learning about quantum computing as well. And we were part of a lot of the hackathons that were through MIT. And we were supporting all of these packages as well for people to compete in. And yeah, it was a lot of fun. I recommend joining these just to kind of meet all the people that are doing quantum as well as just working on quantum computing. Then we also have some documentation that's available for our platform. So with that said, you can actually go launch your lab. And this might take a little bit, but that's totally okay. If you are a new user, it takes a little time. And once that's done, you'll be greeted by something that's similar to this. Oh, and I'd like you to, we're going to give you some access codes for today's demo, and I'd like you to add EHNU 6626. Submit that, you'll be able to access some quantum computing resources through us. So any questions? Has anyone kind of gotten lost at this point? No? All right. Well, in that case, you're going to be greeted by something similar to this screen here. And with that code, you'll be able to access a lot of these packages without ever installing anything. So you'll be able to see that you have access to a lot of these packages here. And so there are packages like IonQ, which allow you to install IonQ related work, and then in PennyLane as well for like quantum machine learning. Today, I'm just going to do Qiskit and probably Amazon Bracket just for this demo. And so if you have ever used a quantum computer, it can be very difficult to actually get started on it, but I'm going to show you very quickly how easy it is. And for quantum computers with Bracket, it's fairly simple. I'm going to activate my Amazon Bracket environment. I'm going to wait for it to connect. It is set up. I can run this line. All right, I've enabled my quantum jobs. And I should be able to import everything without ever doing a single pip install. That's like the benefit of using qBraid. No pip install necessary here. And once that is imported, you should be able to see that. All the gate sets and stuff will be available for you. And if you want to run a small bell circuit, you can code it in Bracket. And you can first run it on a local simulator. Let's get that plotted. And then you will be able to run it on Rigetti as well. Oh, actually I have it on IonQ. So you can actually check which devices are available right now. It looks like IonQ is not available. Let me refresh. But OQC's Lucy is, so let me actually switch to Lucy from AWS. So I'm just going to switch the ID and going to swap this out here. Going to save it. And it's taking a little while, but that's okay. Essentially, once you've done that, you'll be able to run quantum jobs through Lucy and get your status back as well. Then access quantum computers through IonQ and other hardware. So it's as easy as, just kind of getting set up very quickly. There's no really resistance to that, which is really nice as well. So yes, do that. Let's see, I wonder why it's taking so long. Let me actually restart. All right, idle. Going to see if it will take a little less time. If not, I will just wait for this to finish. And you'll be able to recover your jobs as well. Once you submitted a job, it'll show up here. And you'll be able to run quantum jobs. Oh, there you go, it's going through. And so you get your SDKs, and then you'll be able to run your bell circuits, get your jobs on a local simulator. And then I'm going to run it on OQC. There you go. It's already completed. That was great. Should show up here. There you go. My job has completed. I get my job ID, my shots on my circuit. Get it. And then INQ should not actually be available. I'm just going to stop that one. So I've stopped the circuit, but that's okay. You can actually recover your task and submit more jobs if you'd like. And I'm going to actually go recover this task that I ran. And I should be able to get my results back. So that's very good. I got my results back here. Oh. Right. So Rigetti has a compiled program information, but we do not have that here. So let me check compile circuit. Rigetti has an additional metadata because you can actually see which how the gates were transpiled for the device, and we do not have that for OQC. And that's, I think, an interesting part where a lot of these quantum computing backends have different sets of data, but no matter. So there you go. You get your results back. And this was just run on a real quantum computer, and you can do this right now. If you follow through this demo, you'll be able to kind of just follow through and visit all these pages. And what's really cool is I'm going to be able to show you guys an SDK that allows you to benchmark across Amazon Braket and IBM devices. So I think we're the only provider in the world that allows you to do both, and also the open devices as well. So yeah, we did not instantiate the IonQ device because it's not available. I did not turn it on. That is okay. So I'm going to keep moving on here. If anyone has any questions, just shout out. And then I'm going to actually show you guys a new feature we have, which is quantum jobs with IBM. So you guys might have used IBM for maybe if you've taken QWorld, if you have done anything, it's usually on an IBM device because it's free. And so we are now support a lot of the IBM devices as well across. So you can tell that we actually have Qiskits and we actually have the free devices available, and we will have some of the much larger devices available as well with like 16 qubits, all exclusively through us. So you can actually check this out. Oh, yep. This will be available by the end of the month. We will be doing a hackathon at Abu Dhabi, and that's where we'll be doing some testing as well. So. All right, Qiskit's been imported. You've got Qiskit version. You can check that this is actually the latest version of Qiskit. However, we do support Qiskit textbook, which is like the exact version that you need for working on Qiskit when you are using the Qiskit textbook, which is actually available right through here. So if you want, you can actually go through here and you have all the algorithms that are available on the Qiskit textbook here. And it is actually all runnable on the Qiskit textbook environment. So you can actually enable jobs on Qiskit and then run on jobs and do a VQE for, I think this is the hydrogen molecule. And a VQE, essentially you find like the lowest minimum eigenvalue for a simulated molecule. All right. So we have the Qiskit version 0.42.1. That's the latest version. And what we're going to do is we're going to now once again run a circuit. And what's really cool is you now are able to run on all the devices we have available without creating an IBM account or an AWS account, which is very, very cool. And you can use this code, which is the projects and groups that are available on Qiskits. And those are your backends. Let's get Bellum. It usually tends to be the quickest one. And you'll be able to run a job. Should show up soon. Oh. And if you're ever lost and you're like, huh, why is this not working? Why is this supposed to be working? We also have documentation here too. So, oops, sorry. You can actually check out here and we have all the documentation from various places. Has anyone ever worked on like noise mitigation, for example, or air mitigation? So if you're working on air mitigation and whatnot, what's really cool is that we provide Matique, which is the unitary fund package available through us as well. And you can check out their documentation and learn more about what they do here. Oops, so you can actually check out their package and learn more about it. There you go. So you don't have to pip install, it's already available and you can actually start running some of these benchmarkings as well. So that is, I think, great for people who are interested in on a more research side. And you can actually run that as well. All right, let's see if my job has ran. Looks like it has. There you go, my job's been created. It's probably queued up as well in IBM. That is great. And you have the ability to go retrieve a job, go run more jobs as well. And essentially, if you're working on benchmarking as well, you now have all the quantum devices that are typically available across various vendors. So I believe this is really powerful, especially now that we have AWS and IBM. You're not going to be able to get this with a lot of places as well. So I think this is like one of the greatest things that qBraid provides is all your quantum backends are available. And we will have other backends available very soon, such as Quandela. And this is all in your development environment. All right. Before I get into the SDK, I'd like to show that with subscriptions that you can purchase, you actually can get access to Q#, which is a quantum environment provided by Microsoft. So you can actually check it out here. And you can also search up various things here on OmniSearch, which allows you to check GitHub repositories as well as more things about various parts of the on GitHub, Stack Overflow, as well as, so you have someone that's named QWorld. I think you guys have a repository on GitLab, right? Is that correct? Yeah, I think you guys do. We should maybe support GitLab, but so we have all these things that you can use to essentially search for Stack Overflow, Google here, and you'll be able to share notebooks with others who are qBraid users. So I can just share a notebook with one of my other emails, and it'll share this notebook that I've selected right now, which is the Qiskit request. So I just click and it will share. I think it's already actually just shared. And so there's a lot of cool things that you can do here on qBraid. And we also support Git functionality, and you can actually write a lot of your code snippets. Another cool thing that we do provide is compute, and I'll actually show that in a bit. All right, so with that said, do check out our subscriptions and let us know if you're interested. Have you guys heard of Open Source Foundation? Maybe. Okay, it's a great place. If you ever want to know more about other quantum software, you just have to click on this launch on qBraid button and it would actually copy it into your account. And in fact, I am a volunteer at QSF as part of their mentorship program. I help out with their providing credits on qBraid as well as just kind of mentorship, scheduling and whatnot, as well as I'm part of that committee. So if you guys are interested in doing QSF, like that's also a really great program where, you know, they actually provide you, let me actually open this as a markdown. Open with markdown preview. There you go. You actually have all this amazing quantum computing packages available here. And I'd like to today start with the QRate SDK. Should be in here somewhere. I don't remember where on this page, but let me check. There may be some familiar things that you see. Actually, it might just be faster for me to just go to our GitHub. So I'm going to go to our GitHub. So over here you have our QRate SDK, and this will be the last thing I'll show after the compute manager. Same thing here. You can actually launch it on your account. Have any of you guys done any benchmarkings of quantum devices or use a simulator and just kind of ran some random circuits? Anyone? Maybe, maybe not. That's okay. What our SDK does, this will be for demonstration purposes. You can actually get all the devices that are available here, and you can filter them similar to like an SQL query. You can get your devices. Then what's really, really cool, in my opinion, is that you can write a Qiskit circuit. And let me actually zoom in. You can write a Qiskit circuit, then you can actually run it on a Google device, AWS device. You can get all your jobs and then compare all your results without ever writing a circuit in Circ or any of these other quantum computing frameworks. You can check your plots from the simulators. You get good results here. And going back, we can actually use our transpiler that we have that wraps your circuit. Then you can convert it from penny lane to Qiskit, for example. So you can wrap the circuit. This is written in a quantum circuit. So here you have a Bell circuit, and then you have a Qiskit circuit here that you can write in Qiskit, write it into Bracket, into Circ, and it's all working. Then you can actually write it into this random circuit package is from Circ. It's used for their benchmarking, for random circuit benchmarking here. It's pretty large. You have fairly large gates, and yet you can transpile between Bracket, PyQuil, Qiskit, penny lane, and Circ. And it also passes as well. So that is part of what qBraid offers, and you can actually just purchase credits and get started with running a Bell circuit and then getting your task as well. So, all right, that's
Ricky?
about it. Yep.
Yeah, I have a question. Can I ask?
Yeah.
Okay. I would like to know if there any options in your platform, for example, to convert a code from Qiskit to Circ or other frameworks. Yeah.
Yeah, that's exactly what I just showed. So you can actually write your circuit in 5 different frameworks. So you can write this in Circ. You can write this in Bracket and it transpiles. See, it writes it in. So you can write your circuit in any framework you want. And it will actually just transpile it for you with our SDK. Maybe I don't have it installed on this account. It will be open source very soon. I would actually just maybe show this because it's a little prettier. So we can actually apply the device wrapper and send your quantum job. You can view your status of your quantum jobs. We also support all these front ends as well. So for circuits, you can wrap your circuit. You can check the depth write a circuit into Brocket, PyQuil, which is Rigetti. You can run a random circuit, and you can actually treat this as if you're coding in PyQuil or Brocket or Circ and just like transpiling. Exactly. And we actually use a fairly, I forgot the name off the top of my head. It starts with a K, but the transpiling is fairly faithful in making sure that your gates aren't decomposed too intensively, where you won't recognize your circuit anymore. So, and actually, does anyone else have a question? If not, I'd like to show maybe our last year's QC hack. Someone did a really amazing solution here, where we can actually go to the forks. Oh, do I have to sign in? Shouldn't have to sign in. It's a public repository. Forks, there you go. Okay. So Storana did a really cool solution here. There was an intro to Grover's algorithm. The Quantum Crew's solution here actually used our SDK. So they did Grover's algorithm here. They wrote it in Qiskit, and you can actually get all of the devices again. They wrote in on the IBM simulator. They got their results for their, and then they chose to use Amazon Brocket simulators with the qBraid's quantum circuit, SDK. Sorry. So they got their quantum circuit back. They run it on AWS as well. And then they tried it on 14 qubits, used it for 6 qubits. They wrote it again in Qiskit, and they got the results on IBM, AWS, and on Amazon SV1 simulators, Rigetti, and then you can actually check the visualization for Grover search as well. So it's pretty cool. I mean, I think most people write in Qiskit, but you can actually write an Amazon Brocket circuit and transpile it into Qiskit and run it on a free device as well. So, yeah. Any questions? Definitely do check out their solution. I really like it. So.
All right, thank you, Ricky. I guess if you have any questions, we'd be glad to address them. I think it's really great to just have everything integrated in one platform. It will make anything easier for researchers, especially ones who have problems with vendor locking. But using the qBraid, you can just simply work with any QPU available nowadays. And simply they cover all the qubit modalities as well. It's just a complete package. Are you guys gonna cover quantum network packages as well?
We do not, but that's an interesting point. I think we're more focused on like QPUs and whatnot, but you can actually add your own environments and create them too. And you can share those with others. So you know how like if you're making a notebook and you like you share it with someone and then like they are running Windows and it doesn't work. You can actually create your own environment. Maybe I can show you. I do not know if I'm using like a
cool.
yeah. So let me actually show you. So you have to have permission to share some of these, but I think I have permission on this account, but you can actually create your own environment. Test, blah, blah, I don't know, NumPy and maybe NetworkX, right? So I'll just do that, create it. All right, that environment is getting created here. Oh, it's actually in my own environment. It's getting installed. and I should be able to share it with others. So I can actually just start sharing it with someone who has a QBraid account. Did anyone make a QBraid account or not? If not, it's okay, but you can now share environments with others. So it's very easy for you to then have a notebook and make sure that they never, ever, ever have like dependency issues, for example, when they install.
All right. Are there any questions?
Any questions?
Here, just. I don't see anything.
All right.
Thank you, Ricky.
Yep.
It was a great demonstration. I hope people will catch up on qBraid platform. I
Yeah.
want to try.
Yeah, it's pretty nice actually. Sometimes I like forget how nice it is until I do a demo because I'm always working on it. So anyway,
Yeah, I guess with with current diversity among lots of platforms, it is really nice to have such platform to just kind of integrate everything and just work with one instead of many.
Yep.
So that'll make a lot of things easier for researchers, especially.
Yep.
All right. So with that, if you have any concluding remarks or anything you would like to hear it.
All right. Well, I think I'm gonna get ready for work, but I'll see you all and maybe a
Thank
hack.
you.
Yeah, sure.
All
Have a
right.
great day.
You too. Bye.
Bye.
Good luck and bye.